right, so we're going to start with 2.7 continued. All right, and I want to remind you that you have to check for extraneous solutions. Okay? Remember to check for extraneous solutions. So you cannot include one of those ones that are in your restrictions. And that could possibly happen today. All right, so I do want to take it just a little bit further where we might have to do some factoring. If you recall, we did this exact same stuff in May last year. Right, same exact stuff. So here's example number 1, just to remind you what we did before. Let's say I have, let's go with 3x over x plus 5 plus 1 over x minus 2 equals 7 over x squared plus 3x minus 10. So the very first step is to factor everywhere. So we can factor this one, draw x, negative 10 on top, 3 on the bottom. This factors to 5, yep, thank you, 5 and negative 2. So we have x plus 5 and x minus 2. Okay, so first of all, state our restrictions. X cannot equal what two numbers? Good, negative 5 and 2. All right, so now if this is our denominator, x plus 5 and x minus 2, what factor is this first one missing? Yep, so I'm going to multiply my 3x times the x minus 2. Plus 1, what factor is my second term missing? The x plus 5. And then are there any factors that my 7 term is missing? So I just have 7. So that's exactly the same thing as clearing the fraction, right? We could put the whole denominator up there and cancel, or you can think about what factor is it missing, right? Okay, so now we're going to go ahead and distribute 3x times x is 3x squared. 3x times negative 2 is negative 6x. 1 times x is 1x. 1 times 5 is 5 equals 7. Collecting like terms, I have 3x squared. Negative 6x plus 1 is negative 5x. And are you guys okay if I go ahead and subtract 7 over at the same time? Okay, so subtracting 7 over gives us negative 2 equals 0. So now do you guys want to do it by quadratic formula or you want to factor? Factor. All right. Negative 6 on top, negative 5 on the bottom. That would be negative 6 and 1. I'm then going to throw it in the box. So I have 3x squared in the first spot, negative 2 in the last one. My diagonal is negative 6x and 1x. Out of the top line, I can take a 3 and an x. The bottom line, I can only take out a 1. Up and down, I can only take out an x. And up and down, I can take out a negative 2. So my factors are 3x plus 1 and x minus 2. What do I now do with those factors? Set them equal to 0. So our first solution is going to be negative 1/3. Our second solution is going to be positive 2. Are either of those extraneous? So you got to cross off the one you can't have. So in this case, the only solution is negative 1/3. Okay? Do we need to talk any more about this, or are we good? We remember doing this? That was not a lot of work. Okay. All right, so let's go on to 2/8. 2/8, the only thing difference is we now have an inequality. If you recall, when we were doing 2/8 before, when we were doing inequalities before, if I had f of x is greater than 0. Oh, sorry. Let's call it solving inequalities. Inequalities. All right. So if I have a graph, and my graph does something like this, right? And let's call this, I don't know, let's call this 4, and, or sorry, -4, and +4. We want the sections where it is greater than 0, right? So that's where our graph is in positive land. It's in positive land here, and it's in positive land here. Help yourself. Okay, so our solution, if it was greater than 0, so f of x greater than 0 would be from -4 to 0 and 4 to infinity. How would it change if I said f of x was greater than or equal to 0? Yes, it would be bracket. So a bracket -4 to 0 with a bracket, and then a bracket 4 to infinity. What if I wanted to, or I wanted to know, f of x is less than 0? Or, yep. There you go, good. And then if we did f of x is less than or equal to 0, it would be -infinity to -4 with a bracket, and then a u, a bracket, 0 to 4 with a bracket, right? You guys recall doing this before? Okay, so again, this lesson should not be too hard because we've already talked about it before. All right, so whoops, easiest thing I want to do is when you get to this section, the 2 through 6, let's do an example that kind of fits there. So example 1, I guess actually example 2. Okay, you want it as 1? We can go 1. Example 1, and so this is in the 2-8 section 2 through 6. The directions ask you to determine or find where the polynomial let's see, equals 0, is positive, and is negative. Okay? So, and maybe the function we are given is f of x equals, let's go, x plus 2, x plus 1, and x minus 5. All right, so you can throw that in your graphing calculator, or we can graph it up here. Our zeros to begin with, the zeros of this function are?
2,
yep.
1, and 5.
Good, okay. So I'm going to mark those on my graph. I have -2, -1, and 1, 2, 3, 4, 5. Yep. So it's going to look something like this, right? All right, so now I need to know, where is it greater than 0? In this section right here, I agree. So it's from -2 to -1. Where else is it greater than 0? Yep, 5 to infinity. And we also need to know, where is it less than 0 or negative?
All the way from left to
Uh-huh. Good, -1 to 5. Perfect. Okay, so that's all you're having to do for the first few. Okay, and all of them are already factored for you. A couple of them might have like a multiplicity of 2. Do we want to talk about one that's got that on there? It bounces, but you have to make sure that you stop there and then you know what I mean? Because, right. Okay. Yeah, let's do one. Let's do example number 2. Okay, so in this one, again, we want the zeros. We want where it's less, or actually, let's do greater than 0 first, and then less than 0. Oop, greater than 0 and less than 0. or positive and negative. And let's go with the function. Oh, let's make a really good one. A really good one. Let's go with f of x equals x minus 6 squared times x plus 3 times x plus 5 to the third. Yep. So our zeros are at 6, negative 3, and negative 5. All right, so on my graph, at negative 3, I have a 0, and at negative 5, I have a 0. And at 6, 1, 2, 3, 4, 5, 6. Now, this technically is to the 6th power, right? So it technically turns 5 times, right? We know that it has the end behavior on a positive even. The ends are both up. Okay, we know that this one has to bounce off of here because it's an even multiplicity. It's going to do something in between here. Cross through and cross through. That's kind of cross through. Okay, so it's got to have 1, 2, 3, 4. I have 1 too many. Yeah, that's where it's at. I have 1 too many. So I went down here. There's 1, 2, 3, 4, 5. There we go. Something happening in between there. All right, so let's do where it's greater than 0. It is greater than 0 on this side, right? It is greater than 0 in between here, and it is greater than 0 after there. So we are going to do from negative infinity to negative 5. Then we have negative 3 to 6, because it comes all the way down and it's equals 0 there. It's not greater than 0. And then we have to go from 6 to infinity. Then when we are less than 0, where does that happen at? Yep, so negative 5 to negative 3. Okay, but you have to make sure that if you're looking for it and it bounces off, that you've got to stop at that spot because it equals 0 there. Okay. All right, let's do example number 3. Now, in the next one, we're going to do a signs chart. Do you recall doing the signs chart before? You do remember doing it. Do you guys remember doing it? Okay. I asked if you remember the signs chart from chapter 1. Okay. That's what I asked. So here is example number 3. Example number 3, this is going to cover 8 through 12. And it says, solve using a signs table. So for example, let's say I have x plus 3 times x plus 5 squared is greater than 0. So first of all, we have zeros at negative 3 and negative 5. Okay, so in our signs table, we're going to put a dash at negative 5, because that comes first on the number line, right? And a dash for negative 3. Now we pick a number smaller than negative 5 to plug in. Remember doing this now? So if we put a negative 6 in here, we get negative 3. In here, no matter what is this term going to be? Positive, no matter what, right? So we have a negative times a positive. That means this section is a negative. Now, in between negative 5 and negative 3, let's do negative 4. Again, this is a negative 4 in here, makes this one negative, but this one's positive. So we also have another negative, right? And then anything you want to use 0 would make a positive times a positive is a positive.
Whenever you say signs table, I think sign like S-I-N, and I get real strong.
Oh, no, a signs table using positive and negatives. Yes. So if I'm going to answer this greater than 0, where is this greater than 0? Good. Do I use a parenthesis or a bracket? A parenthesis, why, Orion? Yes. So this would be a parenthesis, -3 to infinity. If I was doing less than 0, what would it be? Okay, so remember that if this was less than, so I'm going to go over here and say less than 0, this would be -infinity to -5, and then -5 to -3. Right, there's zeros. Yeah. If it could equal 0, so let's say I put a line underneath this one, then we could go all the way from -infinity to -3, right? We wouldn't have to stop in the middle. Okay? So these few problems you need to do a signs table. Should we do another one? No? You guys sure? Okay, well then let's go to the last one then. Example number 4. Example number 4 is going to cover your 14 through 20. And it says solve. And maybe we have something as wonderful as, let's go x to the third minus 4x squared minus x plus 4, and let's do less than or equal to 0. All right. So, what are we going to do to start with? If this was equal 0, or if it was a polynomial and we needed to find the zeros, what would we do first? Yeah, so we need to find all possible roots first. That's all the factors of 4 over all the factors of 1. Yes, Logan.
Could we get rid of 1x and then put it in here?
No.
Yeah, but, okay, let's take out that. So x squared minus 4x minus 1 plus 4. So minus 1 and 4 is 3. And you put that equation as an x. Okay, but you have to define it'd be plus 4 over x. I feel like that's causing more problems.
I agree with Orion. Now, this one might work as factor by grouping. This one could work factor by grouping. But let's talk about, first of all, we're going to do it like we've been doing them in this chapter. Okay, so out of our factors of plus and minus 1, plus and minus 2, and plus and minus 4, which one of those gives us a 0? How do we figure that out? You can either plug them in and find out if it equals 0, or grab it. You get -1. Okay. So x equals -1, 1, and 4. If you only found one of them, what would you have to do?
Math it.
Yeah, math it. Synthetic division. All right. So, do you want to do this by graphing it or a signs table? Signs table? All right. So what this actually came out to be was the factors of x plus 1, x minus 1, and x minus 4 less than or equal to 0. So in my signs table, I go like this. I have -1, 1, and 4. If you still have your graph up, you may be able to see this. If I go less than -1, so like -5, my first parenthesis would be negative, right? -5 plus 1 is a -4. My second parenthesis would be a negative, and my third parenthesis would be a negative. So negative times negative times negative is still negative. If I put a 0 in there, I have a +1 times a -1 times a -4. What am I going to have? Positive. If I put like 2 in here, I get positive in the first one, positive in the second one, but negative in the third one. Yep. If I go greater than 4, 10, they're all going to be positive. Okay. So now this says, where is it less than or equal to 0? Negative infinity to negative 1 with a what? Good. And then with a 1 to 4. And that's because it's got the equals under it, right? Okay. All right, so you guys think you're good? All right, then I'm going to let you go for it. That way, right now, if you're all going to work, we can cover questions as you come up with them. Make sure that we're solid on all of these as you're going. You can go ahead and, let me see. If you choose to graph it, you know what, I'm going to tell you go ahead and graph it, and if you get some decimals, round the decimal to 3 decimal places and use that for your 0, okay? But only in that last section, not before that last section, okay? I'm okay with doing that.